Okay, guys, we're going to continue talking about the rational zero theorem, okay? And we're going to look at problem number 7 on that paper I gave you yesterday, just because I just kind of want to give you one to look at, to work over one more, okay? So, in the rational zero theorem, one of the first things you need to do is figure out what P is, all right? P is simply the factors of the constant term. So, when we look at negative 8, we have to think, okay, what are all the factors of negative 8? Well, the factors of negative 8 are plus and minus 1, plus or minus 2, plus or minus 3, not 3, sorry, plus or minus 4 is what I meant to say, and then plus or minus 8. Okay, so those are all the factors of P, all right, which is negative 8. All right, so then we have Q. Q is the leading coefficient, the factors of the leading coefficient. So the leading coefficient in this case is 1 because x to the 4th is the variable with the highest power, okay? So that means I look at the coefficient in front of x to the 4th, so it's 1, all right? So then I have to think, okay, what are the factors of 1? Well, that's pretty obvious, just plus or minus 1. All right, so part C says P over Q. So basically you have to take all the factors from P, and oh, that was a terrible line, all the factors from P and divide them by all the factors in Q. Well, Q only has one factor, I mean, it's two factors, plus or minus 1. But basically, P divided by Q, plus or minus 1 divided by plus or minus 1 is going to be plus or minus 1. Plus or minus 2 divided by plus or minus 1 is going to be plus or minus 2. Plus or minus 4 divided by plus or minus 1 is going to be plus or minus 4. And then plus or minus 8 divided by plus or minus 1 is going to be plus or minus 8. All right. So here are all the numbers that I could potentially have to check, okay? So, oh, sorry, and then part D says, hey, how many zeros do I have possible? We'll look at the highest power. The highest power is 4, so I have 4 zeros possible. Now it's time to do part E, which is actually finding which zeros work. All right, I do that by looking at my possible zeros. Okay, so I'm going to look at my possible zeros, and you just pick one. You just pick one. All right, so I'm going to choose 2. There's no real rhyme or reason. I just chose 2. Okay, and now we're going to use synthetic division. So 1, 6, 7, negative 6, negative 8. Okay. Oh, that was a bad negative 8. All right. So I just used this polynomial, my polynomial from the beginning. I'm going to synthetically divide it by 2. Because when I synthetically divide it by 2, that checks to see if 2 is a 0. It also checks to see if x minus 2 is a factor. All right. So I carry down my 1. 2 times 1 is 2. 6 plus 2 is 8. 2 times 8 is 16. That's going to be 25. 2 times 25 is 50. And I can actually see from right now, I'm not going to get a 0 right here. I'll go ahead and finish it out for just in case anyone still does not see that. But, so it's going to be 88. And I get 80. And so that doesn't work. So nope, no success. All right, so we give up on that one. And instead of 2, we'll try, I don't know, let's just try negative 2. I just kind of randomly decided that. Again, I have no rhyme or reason for the ones I'm trying. It's not like I have some trick, okay? So 1, 6, 7, negative 6, negative 8. Okay. So carry down my 1. Negative 2 times 1 is negative 2. 6 plus negative 2 is 4. Negative 2 times 4 is negative 8. 7 plus negative 8 is negative 1. Negative 2 times negative 1 is positive 2. Negative 6 plus 2 is a negative 4. Negative 2 times negative 4 is a positive 8. And I get a 0 remainder. Yay! So that means negative 2 is one of my zeros. It's one of my roots. I could also then say that x plus 2 is one of my factors. That's just kind of some good information. You don't need to write that down. You don't have to say that for today's work, but it's good to be aware that negative 2, x plus 2 would be one of your factors, okay? So we know negative 2 is one of my zeros. So now what I have to do, and for first period, I didn't really mention this very strongly because I tried to show y'all factoring, and I think that lost a lot of y'all. Instead, what I want to talk about today is just, we're not even going to try to factor. We're just going to use synthetic division, okay? Take the same number you just got a 0 with, okay? So this negative 2, all right, you just got a 0, so you know negative 2 is one of your answers, and use it to check it against your new polynomial, okay? So 1, 4, negative 1, negative 4, okay? So I carry down my 1. Negative 2 times 1 is negative 2. I add 4 plus negative 2 is 2. Okay. Negative 2 times 2 is negative 4. Negative 1 plus negative 4 is negative 5. Negative 2 to negative 5 is negative 10. I'm sorry, it's positive 10. Negative 4 plus positive 10 is 6. Did not get a 0. So all that means, maybe you're wondering, like, why did I check it again? Didn't I just realize it worked for this one up here? Yes. You're checking to see if it had a multiplicity of 2. Okay? So if it did have a multiplicity of 2, when you check the negative 2 again against your new polynomial, it would have gotten you another 0. It didn't. Okay? So we know it does not have a multiplicity of 2. Not a big deal. So we know that negative 2 works one time, but it does not work 2 times. Okay, so we've completely checked plus or minus 2. I'm going to try 1 just because that's a simple number to check. Okay. Now, I check 1 against my new polynomial because hopefully each time I'm narrowing down my polynomial, okay, into being smaller and smaller. Okay, so I carry down my 1. 1 times 1 is 1. 4 plus 1 is 5. 1 times 5 is 5. Negative 1 plus 5 is 4. 1 times 4 is 4. Negative 4 plus 4 is 0. Nice! So I have another 0. I know that 1 is another one of my zeros. So then I could also say that x minus 1 is another one of my factors. Okay? So what I have to do is now I check this one again against my new polynomial. Okay? So I'm going to say 1. Alright, and I say 154. 1, 5. Because again, I'm checking to see if it had a multiplicity of 2. Okay? So I carry down my 1. 1 times 1 is 1. 5 plus 1 is 6. 1 times 6 is 6. 4 plus 6 is 10. Okay, not a big deal. It did not have a multiplicity of 2, but I still know that 1 is one of my zeros, one of my roots. Okay, and now I'm still going to use this new polynomial now, 154. Okay, so let's see. Let's check negative 1. And again, I just randomly chose negative 1. There was no real trick to me choosing the negative 1. Carry down the 1. Negative 1 times 5 is negative 1. 5 plus negative 1 is negative 4. Negative 1 times negative 4 is, 5 plus negative 1 is positive 4. Negative 1 times positive 4 is a negative 4. 4 plus negative 4 is 0. Hey, I got another one of my zeros, negative 1. Alright. And so then I know another factor I could say is x plus 1. So now I know I just need one more answer because I know I only can have 4 zeros possible. Now, do y'all see I just have 2 numbers here now? So this polynomial is a very simple polynomial. It's just the polynomial x plus 4. Well, that would be really easy to set equal to 0 and to figure out one of your roots from it. Subtract the 4, so x equals negative 4. That is your last root, negative 4. So then we also know that x plus 4 would be one of my factors if I asked you for the factors. I did not ask you for the factors, I asked you for the roots. But I'm just going ahead and mentioning factors just so y'all are aware. Alright, so then, so that would be all my zeros. So hey, I know that this big old polynomial crosses through the x-axis at these different values. I know that these different values, if I was to plug them in one at a time, like negative 2, negative 2, negative 2, negative 2, where all the x's are, I would get a 0. Alright, this whole thing would become 0. Alright? I just think it's kind of cool that we just know that. Okay? Alright, well, thanks for watching. Let me know if you have any questions. I hope this was helpful. Let me know if it was not helpful. Have a great day.